All right, for this one we are going to be making a soft-faced hammer. Uh, while we make this hammer, we're primarily going to be using the revolve feature on Fusion, which is a very handy feature for anything that has complex geometry that is round. So we are going to start with the hammer handle, and like every other part, we're going to start with creating a sketch. So in the upper left corner, we're going to hit Create Sketch. I'm going to select my ZY plane, and then the first thing I'm going to do is establish a center line. So I'm going to click Line, and in the line options, we have line type here in the sketch palette. We're going to we are going to click center line and then draw a center line with that to establish the axis of rotation. This center line is going to be 9.5 inches long, 9.5. And then I'm going to do a rough sketch, click line again, a rough sketch of the part I am going to be making. All right, that is a very rough sketch. So I'm going to come up to my constraints now, horizontal, vertical, to make sure this line stays horizontal and parallel with my center line. This one stays flat with my base, and now I'm going to start putting dimensioning in. So one of the super handy features of having the center line is that it bases everything measured to the center line off of diameter, not off of radius. So I know that this handle right here needs to be 3/4 of an inch wide. So instead of having to divide 3/4 by 2 and input 3/8, I can actually input the full 3/4 inch dimension, and it will automatically divide that by 2 based on that. So it's giving me a whole diameter measure versus a radius measure. So that allows me to draft things quicker without having to do the calculations myself, which is super convenient. And so I'm going to continue with measuring and defining all of the parts of my print so that I no longer have any of these blue lines. We want all the lines to be white, showing that they are fully defined. And so I'm going to go and define each of these lines based off of what I need them to be. So if I click a line like this, it is asking for radius because it's going the length of the line. But if I come back to sketch dimension and sketch from this line to the center line, now it's basing it off of the diameter. So 0.375 is the diameter I want. Right here, 0.3 is the diameter I want. And here, this point to center line, 0.5. As far as lengths, this length needs to be 1/8. And this length, whoops, not that one, Control Z, 0.625. And the overall length of the hammer handle grip section is 4 inches. All right, so now all of our lines are white and fully defined. I have a half profile. So from here, I can finish sketch. Once I've finished my sketch, I can come up to the upper left and do the revolve feature. If I click that, it's going to auto-populate most of what I need because it already recognizes that I used a center line, and so it's going to default set that as the axis, which is super handy. So not only does it calculate based off diameter versus radius for me, but it is also going to automatically populate that as my axis of rotation. And then it's going to select the only profile that was there, which was my sketch profile. And it defaults to 360 degrees, and by doing so, I have a full spherical handle. Not spherical, round handle. Hit OK, and that is our hammer handle. Next thing I want to do is establish my threaded portion, which is this tip right here, which is where our head is going to thread on. That is going to be 3/8 24 thread. So I'm going to come up here to the upper left, and the hole function, I'm going to click on that, and then select. It's going to ask what face or sketch to select. I'm going to, whoop, why is it trying to go sideways? Cancel, hole. Oh, my dumbass keeps doing hole. I'm going to page down to thread. Yeah, okay. That's my bad. Anyway, so once we've selected thread, not hole, thread, we're going to select our cylinder. It's going to auto-populate, so it knows it's 3/8 already because that's the diameter. So it's going to auto-populate to ANSI, which is the unified screw threads, and a 3/8 thread. So we're going to page down to 3/8 24, which is what the physical print I have calls out for. I'm going to select that, hit OK. Now it's going to give me a cosmetic showing the threads are there. Down here in the threads section, I'm going to right click and rename. I'm going to rename that 3/8-24. So that way I know exactly what my thread spec is without having to open this up. I can just page over. I know that that's going to be a 3/8-24. I can see the cosmetics. I know a thread is going to be there. With that, we have finished our handle. So we're going to save that as hammer handle in soft face hammer. Save. So now that we have our hammer established, it was pretty easy to do with the revolve feature. Quick, easy, less than 5 minutes. And now we can start working on the hammer head. So I'm going to open a new tab by just hitting the plus to open a new design. Create sketch. XY plane. I'm again going to draw a line. Click line and then click center line to establish a center line. I'm going to use horizontal vertical to make sure it's horizontal or vertical in this case. I'm going to establish its overall length, which is going to be the length of my hammer head, which is 2.75 inches. And from there, I'm going to start drawing a rough approximation of a half profile. Again, it only has to be a rough approximation because I am going to be dimensioning it. Ooh, this is a very rough approximation. I am going to be dimensioning it with constraints. So I'm going to start with collinear because these two are supposed to be the same, and collinear, the same as this one, and this one being collinear, and then horizontal vertical. So this line is supposed to be horizontal. Actually, they're all supposed to be horizontal vertical. So anything that doesn't have a right angle constraint, keeping it there, I'm going to then force it into that constraint. So now I'm going to start dimensioning. So this right here is going to be 1.25. The gap between our threads, which we can see right here, is way bigger than it needs to be, is going to be 1/8, 0.125. And then I'm going to use the equal function to make this line and this line equal at 1/8. I'm also going to use the equal function to make this line and this line equal. And now I am going to use the collinear to make sure, wait, I've already made those collinear, so it doesn't matter. Now I'm going to start doing diameters. So this right here has a diameter of a 1/2 inch, 0.5. This is going to have, cancel. This right here is going to have a diameter of 0.4. And this right here is going to have a diameter of, let's see, 1 inch. So that has established a half profile. So again, since we have a center line, it's giving me diameter-based measurements, so it's quicker, easier. And then using the constraints, making these collinear here and here and here and here, I don't have to measure for each one to the center line. I measure once and it changes both. So again, I'm going to finish sketch, go up to the upper left to revolve, click my revolve function, and there I have, again, it auto-populates, and I have my revolved hammerhead. From here, now what I'm going to do is add my threads in. So in the drop down and create, bring down to thread, select the 2 cylinders that are going to be threaded. So this one, which is going to be a 1/2 inch, and this calls for 1/2 inch 20, UNF, okay, and then whoops, cancel, drop down from create into thread, select the other one, 1/2 inch 20, again it's auto-populating with 1/2 inch threads because that's what I'm selecting, hit OK, and there I have the 2 threaded ends where our soft faces are going to screw in. If we're curious about the dimensions on anything, we can click the inspect and measure from face to face to get an overall dimension, which is right here, 3/4. But right now we're not finished because we need to be able to screw this onto our hammer handle. So what we need to do is create a hole in the side. So what I'm going to do is construct a tangent plane. So here in construct, I have a drop down. And these are all the different types of planes and axes and points I can place on my part. So what I'm going to do is select tangent plane, which is going to ask me a face of a cylinder. I'm going to select this cylinder. And by doing so, it's created a plane which is tangent to that cylinder. I can select the degree of tangency I need. 0 degrees is fine. And I can hit OK. And so now I have a tangent plane to build off of. So what I'm going to do now is create sketch, select my tangent plane, and now I can put a circle right there. So now that I have this circle here, I need to put a dimension on it. So it is going to be from the origin 2.75 divided by 2, which is going to put it in the middle. And also, I'm going to select the horizontal vertical, select this point, and my origin point. What that's done is it's made those 2 points, an imaginary line through those 2 points, exactly vertical. And so the last thing I need to do is define the diameter of my hole, 0.33. All right, so I have a circle established on the center of my part now. I'm going to finish sketch. From here, I can create a hole. I'm going to select that, select the hole I've just drafted. In the drop down, I'm going to do all the pertinent information. So the hole type is a simple hole. It is a tapped hole. There is no thread offset, so it's a full thread. Drill point is angled. It is a 118-degree drill. I am going to be drilling with a 3/8 and a 3/8 24. And so as I'm selecting these, it's auto-populating the rest of my information. So the depth of my hole I do need to establish, which is a 0.78. Class 2B, right hand, and I can hit OK now. So I now have a 3/8 24 threaded hole. So now what I'm going to do is right click, rename 3/8-24. The same with these ones. Rename. That is a 1/2 by 20. And then in parentheses, because it won't let me name them all the same thing, 2, because this is technically the first one. And so select that, rename 1/2 by 20. So now I know what the thread pitch on all of these are by just paging over them. And that will finish out my hammerhead. So I'm going to go ahead and save. Hammerhead. Save. All right. Now the next thing I'm making is the faces that are going to screw on here. So again, I'm going to make a new design, upper right corner, create sketch. Now for this one, it's much simpler. So I'm not going to use a revolve at all. What I'm going to do, select my plane, just do a circle, and my hammer face is a diameter of 1 inch, and it is 1 1/4 long. So I'm just going to hit the hotkey E, which is for extrude instead of revolve. So I'm just going to hit E and establish it's 1.25, 1 1/4 inch long. And that is the cylinder for my hammer face. Now I do need a chamfer on this, so I'm going to use the chamfer function right here in modify. Select this corner, and it is a 80 thousandths chamfer. Hit enter. There's my chamfer. And now in my construction, in the drop down, I'm going to do point at center of circle, sphere, or torus. And then I'm going to select this circle. By doing so, it's put a point in the middle of that circle. I'm going to hit OK for that. And now I'm going to select hole in the upper left. It's going to ask me where. I'm going to select face, reference, select point, and so then it has put it on that point and the face. Now for this hole, it is going to be a 1/2 inch, so I'm going to page down to 1/2 inch, 1/2 inch 20 UNF to a depth of 7/8. So 0.875. 2B. So I have a simple hole, tapped, full, angled tip, 118 degrees, which is our standard drill tip, and it's a 1/2 inch, 1/2 inch 20. Okay. So this was a quick and easy thing to do with an extrusion rather than a revolve, because this is a much simpler cylinder. So that was quick, easy to do. Now, I am going to change the material of this. So the material, this gray material as it is, when we draft parts, it defaults sets the material to steel. Now, this is going to be a soft face hammer, so the two faces are going to be two different materials. So I no longer want this to look like steel or be steel. So in the bodies section right here, I'm going to click the drop down. Over body 1, I'm going to right click, page down to physical material. In physical material, I'm going to come down to my metals folder right here, and I'm going to select aluminum 6061. aluminum 6061, and drag that up into this design area. And once it's there, I can click and drag again onto body 1. Close, and just like that, we see it's become lighter because now it's 6061 aluminum, and it will show in the bill of materials as 6061 aluminum now. So I will save that as AAL soft face. Save. Now, what I'm also going to do in the file drop-down here in the upper left is save as. In the save as, I'm also going to do brass soft face. Save. So now, if I go into my show data panel, I have my AL soft face right here and my brass soft face. So I'm going to close this up. And what I'm going to do now is it's the exact same part, but I'm going to right click physical material. I'm in the brass one now. In material, I'm going to come down to brass and soft yellow, drag that up, drag that over, close. So now I have this identified as brass, and I'm going to come into the upper left, save. User save, okay. So now I have a brass one and an aluminum one. Now, one more in new design. Once I'm here, this is where I'm going to do my assembly. So in this page, I have all my parts done, so I'm going to come over here in the assemble section, insert components, soft face hammer, hammer handle, insert. And there is my handle. I'm going to hit OK, back up to assemble, insert component, hammer head, insert. Now the hole is going the wrong direction, so what I'm going to do is grab this and rotate it around 180 degrees. Okay. So when the first part imports, it's fixed. We can see that by the anchor here on the hammer handle. But the second part is loose. It floats around. So I'm going to have to now join it in place. So up here in assemble, I'm going to click the drop down, and joint is what I'm going to select, or I can hit J on my keyboard for the hotkey. So I'm going to select the face of this with the face of that and make that motion a rigid fixture. Once I hit OK, these two pieces have now been fixed together in a rigid motion, so I can't grab it and move it anymore. Now I'm going to import my next piece, so assemble, insert component, brass soft face, insert. There's my brass soft face. Just going to move it over so I can see it, hit OK, and do the same thing where I'm going to hit J, which is the hotkey, for join this face and axis with this face and axis. And that's going to join it together. Hit OK. That's again a rigid motion. It's showing me that by these symbols here. Now I'm going to insert component, aluminum soft face, insert. It's facing the wrong direction, so I'm going to rotate it around 180 degrees. Grab the arrow to move it so I can see it better. Hit OK. Now I'm going to hit J again for joining. Select this face and select this face axis. And just like that, we have assembled our soft-faced hammer. Everything is rigid, everything is pushed together. Now, if we want to see inside of this, to see how our thread clearances are, another thing we can do is under inspection here, use our drop down and come down to sectional analysis. We're going to click that, and then we are going to click our Z plane, our ZY plane right here, and it is going to give us a sectional analysis of our part. It's going to split it right there. I can hit OK, and that shows us where our thread intersections are, how much clearance we have between the bottom of our threads, how much clearance we have over our reliefs, and where each part is. Obviously is colored a different color so you can see what's going on. Sectional analysis can be a very useful tool when you have a lot going on and need to see how things are fitting together. To turn the sectional analysis off, here in our work tree we have analysis. We can open that up and see we have the sectional, and we can turn that off and our part comes back. In our relationships we can see our joints. We can turn that off so we don't see those joint symbols anymore. And we can also turn off and on various parts if we need to look at what's going on. Anyway, hopefully that was helpful. I'm going to save this as hammer assembly. And that should be it for this project. Hopefully it was helpful. Hopefully you learned something. And good luck, have fun.